Now I wanted to focus on this next example because this is probably one of the easiest mistakes that students make. It's a mistake that I make all the time when I'm trying to do these problems, and I really have to stay focused, okay? This problem looks very simple on its face. We've got a 4 kilogram mass right here at the origin. Up here we have a 20 kilogram mass. It's a distance of 3 meters away, making an angle of 30 degrees with the horizontal. Just to give that all again, 4 kilogram mass at the origin, 20 kilogram mass up here, 3 meters away, angle of 30 degrees with the x-axis, with the horizontal, okay? We're trying to figure out the net force on the 20 kilogram mass, but we want to do it in unit vector notation. We want to find the net force on the 20 kilogram mass in unit vector notation. Calculating the magnitude of the force of gravity is very easy. We've already done it in the previous examples. Force of gravity is equal to big G, M1, M2 over R squared. That's going to be equal to 6.67 times 10 to the minus 11. And if you guys aren't already doing so, you can pause these videos to make sure that you know what the next step in the problem is. I'm going to do a couple more examples of these things. Go ahead and pause the videos and see if you get to that point, or if you make any mistakes, that gives you an opportunity to go back and see what you did wrong. 6.67 times 10 to the minus 11, don't have to worry about units, they're both in kilograms. 4 kilograms multiplied by 20 kilograms divided by the distance between the two guys, and we get a force of gravity magnitude of 5.93 times 10 to the minus 10 newtons. 5.93 times 10 to the minus 10 newtons. Okay, now when it comes time to figuring out the force of gravity in unit vector notation on this guy, we've got to be really careful. Looking at the 20 kilogram mass, he is attracted along the r vector, along the 3 meters toward the 4 kilogram mass. So this is the force of gravity right now. It's angled downward toward the 4 kilogram mass. We know that that makes an angle of 30 degrees down here, an angle of 30 degrees. We want to figure out the force of gravity in the y direction, which is going to be pointing down, and then the force of gravity in the x direction, which is going to be pointing to the left. So what we need to do is we need to actually break this guy into components. Here's the mistake that a lot of students make. A lot of students say, oh, I'm just going to break the 3 meters down into an x and a y, and I'll use that in my r when I'm calculating the force of gravity along x and y. You can't do that. The vectors do not behave like that. You need to calculate the force of gravity first, using the distance of 3 meters, and then break it down into components. That's the mistake I always make. I try to get a little tricky on this. Always calculate the force of gravity first, then break it down into components, okay? So we've got this force of gravity right here. It's angled here. In order to get the y component, we need to multiply that force of gravity by, it looks like the sine of theta, the sine of 30 degrees. So to get the y component, FGY, we need to take FG multiplied by the sine of 30. So that would be 5.93 times 10 to the minus 10 multiplied by the sine of 30 degrees. And we get a force of gravity in the y direction of 2.96 times 10 to the minus 10 newtons, okay? That's directed down, okay? According to my diagram, that's directed down, so I'm going to say that's down right now. To get FGX, we're going to do FG times the cosine of 30. That's 5.93 multiplied by 10 to the minus 10, multiplied by the cosine of 30. And yeah, you're going to have some really weird numbers in this chapter. I'm going to do my best on any kind of assessment that I give, since I have to give it online. I'm going to do my best to make sure that we keep those numbers nice. I might just have you give all of your answers in terms of big G, 6.67 times 10 to the minus 11. FGX is going to be 5.13 times 10 to the minus 10 newtons. So now we put these two guys together in unit vector notation. Keep in mind that this is to the left, so I'm going to have two minus signs, one from the downward FGY and one from the leftward FGX. And I get that FG in unit vector notation is negative 5.13 times 10 to the minus 10, and this is in the x hat direction, notice the minus sign, and then minus 2.96 times 10 to the minus 10 y hat, also in the minus direction, and then we put a Newton on there to signify our units. Okay, very straightforward problem, but you have to remember to break it down into components after you calculate FG.